In this video, we are going to review the study guide for an upcoming test on quadratic functions. And recall, a quadratic function means it has x to the second power. Folks, the first thing you need to recognize is that when they ask for the axis of symmetry, they're talking about the line that separates the parabola into two equal parts. See that word axis? Where have we seen that before? We've seen that before to describe the x-axis or the y-axis. That is a line, whether it's the x-axis or the y-axis. So it turns out that the axis of symmetry is the line that divides a parabola into two equal parts. So if that's your parabola, if this is your parabola, the axis of symmetry is going to divide it into two equal parts. It's similar to someone's face. The axis of symmetry of someone's face would be right down the middle because the face is the same on this side of the line as it is on that. That is the same with a parabola. Now, something very unique about the axis of symmetry. If you look at the vertex of a parabola, recall the vertex is the turning point. There's the vertex. That's where this parabola, which was going down, turns and now is going up. What you'll notice is that every vertex has an x and y coordinate. It turns out that the equation of this axis of symmetry and the x coordinate of the vertex are exactly the same. So once you find the x coordinate of the vertex, and I'm going to show you how to do that in a moment, you then, by definition, also have the axis of symmetry. Okay, let me give you an example of that. Okay, let's say you have this parabola. Okay, and this parabola, again, this has nothing to do with number one. We haven't gotten to that yet. This parabola, let's say, is located like this. Okay, it's going down. Its vertex is right here. Okay, and let's call that axis of symmetry right there. Let's call that x coordinate 5. Okay, so this axis of symmetry, the equation of that axis of symmetry is always going to be x equals something. Okay, that line crosses the x-axis at x equals 5. Well, folks, this vertex right there, which is a maximum point because the parabola is pointing down, that vertex is going to have an x and a y coordinate. Guess what the x coordinate is? It's none other than 5. Okay, so the vertex is going to have this x coordinate because the axis of symmetry is at x equals 5. Okay, let's now go ahead and go to the first problem, and I'm going to show you now how to find the vertex, and that by definition is going to give you the axis of symmetry. Now, there are two ways to present a quadratic equation. Actually, there's more than that, but this is the so-called vertex equation. All right, you may have seen it written like this: y equals a times x minus h squared plus k. Now, your vertex is going to be the coordinates hk. But notice something. See that negative sign in front of that generic equation? That means when you determine from the vertex equation what the h coordinate is, you put a circle around whatever's in parentheses and its sign, and as you pull it out, you change the sign. So the h value or the x value is going to be -4. And that's because the generic equation has that negative. That means do the opposite. Now, what about the k? You see that plus sign right there? That means whatever you see in the real world equation, okay, in this case, we have -3. Whatever that is, when you circle that with its sign, it stays the same. Okay, so there is your vertex. That's why they call this the vertex formula, because it's very easy to pluck out the vertex. It's right there for you. Again, put a circle around what's inside of the parentheses, Get rid of this so it's clearer. You put a circle, whatever's inside the parentheses, and as you bring it to your answer, this is the vertex, V for vertex, you flip the sign because of that negative. Here, when you get the y coordinate, it stays as is. So folks, what is the axis of symmetry for this? X equals -4. It's the x coordinate of the vertex. Okay, so that is choice A. I'm sorry, that is, that is letter A. Let's do now B. Now notice, this is not in vertex form. See how that x squared is out here? This has been expanded. Not only that, but if we have y equals, this is called standard form, ax squared plus bx plus c, there is no b term, it's gone. So if you were going to rewrite this with hidden ones and zeros, like I like to do, you would have 2x squared plus 0x plus c. So now your b value is 0. Now why is that important? Because the x coordinate of the vertex can be found by using this formula, -b over 2a. That is the x coordinate of the vertex. It's also going to be our axis of symmetry. Recall, they are one and the same. So let's do -b over 2a. Here our b equals 0. We pattern match. See how that matches to b? So b equals 0. What's our a value? We pattern match. A equals 2. Okay, so -b is going to equal -0. 2a is going to be 2 times 2, which is 4. So the x coordinate of the vertex is going to be 0. So let me put that here. This is v. It's going to have an x and a y coordinate. Our x coordinate is going to be 0. We don't know our y coordinate yet. Okay, but what we do know is the axis of symmetry. The axis of symmetry matches the x coordinate of the vertex. I know I sound like a broken record. Okay, so the axis of symmetry, which is abbreviated as AOS, is going to be x equals 0. These match. Now, folks, how do we find the y value? Don't forget, the vertex is going to have 2 coordinates. Very simple. The way we find the y coordinate is we take this x coordinate, x equals 0, and we plug in 0 for x, and whatever our y value is, that's the value, the y value of the vertex. So we're going to have y equals 2 times 0 squared minus 4. Okay, all I did was take x equals 0 and plug that in. Y equals 2 times 0 minus 4. This is going to be 0. Therefore, the y value of the vertex is going to be -4. So we're going to go ahead and we're going to replace this question mark with -4. We now have our vertex and we have our axis of symmetry. Let's move on to number 2. They again want the axis of symmetry and the vertex. Okay, we know that the vertex is going to have 2 components, an x and a y, or 2 coordinates, and we know the axis of symmetry is going to x is going to equal something. Both of these formulas, both of these equations, are in standard form. They are not in vertex form. We cannot pluck out the vertex. So we are going to use x equals -b minus 2a. That's going to get us the x coordinate of the vertex, and it's also going to get us the axis of symmetry. Here, a equals 1, positive 1. B equals -1, and C equals -9. But I'm not even going to write that down because we don't need that for the formula. So the x coordinate of the vertex is going to be the opposite of b, -b. So here b is -1. We're going to change that to +1. Over 2 times a. A is +1. We're going to do 2 times 1, and that's going to equal 2. That is the x coordinate of the vertex. So I'm going to go ahead up here. Here's our vertex. I'm going to take that x value out, and I'm going to replace that with 1/2. Okay, we obtain that by using negative b over 2a, and now I have my axis of symmetry. So I'm going to take this question mark out, and I'm going to replace that with 1/2. Okay, here's our AOS, axis of symmetry, and we have the x-coordinate of the vertex. Okay, folks, how do we find the y value? Remember, f of x can be replaced by y. They are one and the same. All right, so let's now take x equals 1/2 right here, and we're going to take this value, we're going to plug it in anywhere we see x, and whatever it evaluates to, that's going to be y, and that is going to be the y value of the vertex. All right, so we are going to have y equals 1/2, if it helps, put it in parentheses, squared minus x, which is 1/2, minus 9. That's going to be y equals 1/2 times 1/2 minus 1/2 minus 9. Okay, whenever you are multiplying fractions, you are allowed to multiply straight across. All right, let me make some room here. Apologize for the delay. All right, we're trying to figure out the y value of the vertex. So 1/2 times 1/2 is going to equal 1/4 minus 1/2 minus 9. Okay, we cannot subtract 1/4 minus 1/2 because the denominators are not the same. So we are going to change 1/2 into 2/4 minus 9. 1/2, I'm sorry, this should be 4, I apologize. 1/4 minus 2/4 is going to be negative 1/4. And we're going to change 9 into 36 over 4. So our final answer for y is going to be negative 37 over 4. That is going to be the y value of the vertex. So I'm going to go ahead and replace this with negative 37 over 4. Okay, let's move on to problem C. Let me quickly review what the steps are. When you have an equation in standard form like this, otherwise known as ax squared plus bx plus c, step 1 is to use the formula x equals negative b over 2a. You pattern match to get the b and the a. This x value, whatever you get, will be the x-coordinate of the vertex, and it will also be the axis of symmetry. Okay, so let's say I'm going to let negative b over 2a equal, I'm going to let negative b over 2a equal this asterisk, whatever that is. Whatever that value is, it is the x-coordinate of the vertex, and it also goes with the axis of symmetry. Now, how do we get the y value? To get the y value, okay, step 2 is to find the y value of the vertex. Let's do that in green. To get that, you plug in the asterisk, whatever that x value is, for x, and then you solve for y. And whatever that y value is, that is the y value of the vertex. Okay, let's now proceed and do part C. Okay, what are our 3 steps? This is in standard form. Step 1 is to use negative b over 2a to get the x-coordinate of the vertex. Okay, here's our vertex right there. A is going to equal positive 1. B is going to equal negative 2. Okay, if we circle this, that's our b value, negative 2. Now, that negative b means we're going to take the opposite of what we see. We're not going to take negative 2, we're going to use positive 2. That is the opposite of what you encircle. 2a is going to be 2 times 1. So we're going to have 2 over 2 equals 1. That is not only the x-coordinate of the vertex, it is also the axis of symmetry. Now, how do we find the y value? We take the x-coordinate of the vertex and we plug it into the equation to get our y value. We take this f of x, we cross it out, we replace that with y, and now we're going to take this one value, we're going to plug it in here anywhere we see x. So we are going to have y equals 1 squared minus 2 times 1 plus 10, y equals 1 minus 2 plus 10, y equals positive 8. Folks, that is your coordinates of your vertex and the axis of symmetry. Again, x-coordinate of the vertex matches the axis of symmetry. Okay, let's now move on to number 3, and you're asked to do the same thing with these two problems or equations. Find the axis of symmetry, so we know that's going to be x equals something, let's call it an asterisk, and find the coordinate of the vertex. And that coordinate of the vertex is going to be x comma y, and the x value is going to be the same as the x value of the axis of symmetry. All right, so let me replace this with the asterisk. Okay, and recall that negative b over 2a equals the x value of the vertex. Let's call it the asterisk. All right, now the problem is, folks, we don't have this in ax squared plus bx plus c format. All right, you don't see an x squared here or a bx or a c. So what you can easily do is FOIL this part and then multiply everything by 2. So let's do that. Let's go ahead and FOIL this. In a sense, I'm going to put brackets around this. All right, I'm going to leave that 2 right there as is, and I'm going to FOIL this. So if we FOIL that, we have x squared plus 4x minus 2x minus 8, and that's going to give us x squared plus 2x minus 8. Okay, recall that was in a bracket, but this 2 is still there. So what are we going to do with that 2? We're going to distribute. We're going to get our arrows going. All right, so this is going to equal 2x squared plus 4x minus 16. Now, folks, we have our a and our b, and we could plug into there and do this problem just like we did the other two. All right. Now let's move on to this one here, and I want to show you how to do that a little bit differently, only because, well, actually, to review, this is not in standard form. So what we can do, folks, is FOIL this. This becomes x squared minus 17x minus 18. And again, we would use negative b over 2a to get our x-coordinate of the vertex and the axis of symmetry, and then plug that in to get y. But folks, you may see this same equation and be asked a different question. Namely, what are the x-intercepts? So just in case you see an equation like this, and they ask you for the x-intercepts, let me show you how to do that real quickly. Okay, here's our axis, x and y. Here's our x, here's our y. Now the x-intercepts are where a graph crosses the x-axis. Okay, so if that's our parabola, these are the x-intercepts. Let me do a different color. These would be the x-intercepts right there. Now, what do you notice about the x-intercepts? You notice if you're right on the x-axis, no matter where you are, your y value is 0. Because look, that black dot, you're not up, you're not down, you're right at 0. Same with this one. So the way you find these, okay, I'm going to put question mark because we don't know what those are. The way you find them is you take this y and you set it equal to 0. And whatever x values here make that y value 0, that'll be our question marks. How do you do that? You take each of these factors, okay? So again, we're going to set that equal to 0. We're going to take this and set that equal to 0. And we're going to take this and set that equal to 0. And now we're going to solve for x. Okay, how would you solve for x here? We have a neighbor that's being added to x. We know how to do this. We subtract 1 on both sides, and we get x equals -1. Okay, and to check yourself, if you take -1 and put that into that parentheses, -1 plus 1 will indeed give you 0. Okay, now the other side, to solve this equation, we're going to add 18 to both sides. Our final result is going to be x equals 18. Check yourself. If you plug in x equals 18, you're going to get 18 minus 18, and that is 0. So folks, for part B, if they asked you what are the two x-intercepts, they would be x equals -1 and x equals +18. And because there's a hidden +1 out here, this would be a right side up parabola. And because it's a +1 right there, it's hidden. It would not be wide, it would not be narrow, it would be perfect. And our vertex would end up down here somewhere. Moving on to number 4, we have a multiple choice question here where they want the quadratic function whose graph has a vertex of 5, 1 and a y-intercept of 0, -24. Okay, I always advise students to go ahead and draw this. Sometimes it gives us some intuition here. Okay, so our vertex is going to be 5, 1, which is right there. Okay, that's the point 5, 1. And the y-intercept is going to be 0, -24. So where is the point 0, -24? It's down here somewhere. Okay. And this is the number 5, 1. Okay, so if this is our vertex and our graph has to cross the y-axis down here, we know, folks, that we're looking at an upside down parabola like this. All right. Now, if we know that our parabola is upside down, we know that the sign out front has to be negative. So which of these have a negative sign out front? There's only one of them. It's right here. There's your answer, choice A. Look, here's a positive sign, here's a positive sign, positive sign. That's the only one that fits.